So today I'm going to have a look at the same problem that we've seen last time, but I'm going to solve it using a different technique. And the technique is called wishful programming. So takes its name from wishful thinking, which is basically this. Thinking in which what one wishes were the case is believed to be real or likely to become real. So we're going to address this part here. So likely to become real. So what I mean with that is that we're going to assume that certain methods or certain parts of the algorithm are already working. And then we're going to build the rest of the algorithm on this assumption. So let's revisit the problem that we were facing last time. So we have an array and we have to return all indexes that are said to be balanced when the sum of the elements at its left is the same as the sum of the elements at its right. For example, in this case, left of index 3, we have 2, and right of index 3, we also have 2. So this index here, 3, is said to be balanced. So let's approach the problem. What is the bigger concern that I have here? Is that I'm not really sure how to implement this balanced concept. So in a nutshell, I'm not really sure how to implement an isBalanced function. So what I'm going to do, I'm going to assume that I already have it. I would love to have this function. Private Boolean is balanced, that takes an array and takes an int index. And this returns whether that index is balanced in that array. And I'm just going to write the minimum amount possible to make the compiler happy. So the key here to finding which functions you want to stub or which function you want to write in this way is to ask yourself, what is that part of the algorithm that I would love to already have? And that's usually the thing you want to start with in this way. So I'm going to say that I would love to have an isBalanced method, and that's what I wrote. So now I'm going to write the rest of the algorithm, assuming that this is correct. So the rest of the algorithm is a method, sorry, that is called, let's call it this way, solve wishful, which accepts an array of integers. And what is the algorithm here? Well, I have to go through all the array, and for each index, I'm going to check if that index is balanced or not. If it is balanced, I'm going to add the index to a list, and at the end of the algorithm, I return the list. So let's do just that. I'm going to copy paste a bit the part that we already seen. So this is my solution. And then this is the array that goes through the loop that goes through the array. And if the current index, which is I, is balanced, then that is part of the solution. And so I'm adding it to the solution. At the end, I return the solution. So what I wrote here is exactly what I said. And so now I can focus on the isBalanced function that I've left behind. So let's also approach this function bit by bit, implementing it just in small steps. So what the first step would be. So as we recall, the definition of a balanced index is an index is said to be balanced when the sum of the elements at its left is the same as the sum of the elements at its right. So the sum of the elements at its left, which is int sum before, and the sum of the element at its right, and so and sum after. So when these two quantities are equal, then it's balanced. And so I will write just that. Two quantity are equal, then it's balanced. So this is the first implementation. Now I'm going to code this bit here. So how do I get the sum before? Well, I have to go through the array and stop at the element before the index. So how do I do that? Well, I do a for loop that goes from I equals to 0 to I less that index. Sorry, less. So I'm not going to finish at the index, but at the element before it, which is guaranteed by the less than, and then I plus plus. So what do I have to do in this case? I have to sum before with self and to the value at that position. Value at that position is this one. And so I'm done with this. Now I have to tackle this problem here, this sub-problem here. So the key is all here, finding sub-problems. So I want to do a loop starting from the position right after my index. So this is my index. So I'm at this index 3, 0, 1, 2, 3, index 3. And I want to start from the element right after it. So this element here, this index here, sorry. The index after that is index plus 1. I also want to stop when the array is finished. And I want to go one element at a time. And at this point, I'm going to add some after to the current position of the array. Okay, and that's it basically. Now all I want to do is see if it works. And yes, it works. So what are the major takeaways here? So in wishful programming, you basically think, what's the most useful function that I would love to have right now, already implemented, that I don't want to code because it's too difficult right now in this scenario? I said it was this one. So the knowledge of whether a certain index is balanced or not. And so I assumed it working. I've coded all of the algorithm based on that assumption. And then I went back to here and implemented step by step. So starting from the definition, I found out that I needed a sum before the current index, a sum after this index, and then I had to check the two sums. And this is another way of approaching the problem. And yeah, if the noise is ended, well, yeah, also the video ended. So that's all I had for today.